All right, guys, so I want to go over electron configuration with you and this gizmo. All right, so first thing I want you guys to remember is that you have the electron configuration on the periodic table. Okay, so remember that the first two columns, all right, the first two columns are going to be, so remember this column are going to be your S. Okay, they're your S. And you can see here in little box, we got 1s, 2s, 3s, 4s, okay, and so on. Over here in the green, you've got P. Okay, so this is your P right here. And again, it's showing you the level, the energy level that you're in. So 2P, 3P, 4P. Now remember that helium over here, okay, is placed over here, but it does have an S. It is in the 1s level, okay? So don't forget about helium over here. In the middle, you've got this pink or red, that's your D, okay? And then down here in the purple, you've got your F. All right, so just remember that. So when we go to our gizmo, all right, remember to always read all of the instructions, okay? I'll return it to you if it's not complete, all right? So I want you to take your time and really go through every question and answer every question that you have. All right, so let's just take a look. This is going to be our warm-up, all right? So to begin, check that lithium is selected on the periodic table. Okay, so here's our periodic table over here. Okay, and I am gonna, you can select lithium. This is way off, sorry. Lithium right here. Okay, and so I'm gonna click it, and there's lithium. We've got the atomic number on the top and the average atomic mass on the bottom. Okay, so remember that the atomic number is equal to the number of protons. Okay, a lot of you said neutrons, but it is protons. Okay, so how many protons are in your lithium atom? Okay, you're going to put that. Now remember, a neutral atom. Okay, so a neutral atom, let's highlight that. Okay, whoops. A neutral atom has the same number of electrons and protons. Okay, so how many protons does it have? You'll put there, and how many electrons. All right. Now, select the electron configuration tab and check that energy is selected. Okay, so we're going to come over here, electron configuration tab. Now, here you've got a lot of different things that you could choose. Okay, so you could choose your energy number down here. Okay. It's got some more check marks down here that you can use. All right, you can check your answer, you can reset, and then you can go to the next element if you have to. All right, so select your electron configuration tab and check that the energy is selected. Okay, it is selected. Click twice in the 1s box. Okay, so I'm going to click twice at the lower left and once in the 2s box. Okay, observe the atom model at the right. So now we're going to look over here at the electron model. Okay, so when you do that, whoops, okay, this is what they're talking about. So we've got two atoms here, really close, and then we've got another electron out here. Okay, so two electrons circling here, those are in the 1s, and then one electron out here in the 2s. All right, what do you see? So write that down. Write down what I just said. Click check. Is this electron configuration correct? Okay, so the electron configuration, remember, has like the 1s, 2, 2s, 1. You looked at this last week. All right, so let's hit check, and it says yes. Okay, the correct electron configuration right down here below where it says check, reset, and next element. Okay, so is it? Well, you have to answer the question. Okay, so get the gizmo ready. on the periodic table, so we have to change to the periodic table, select H. Okay, so I'm going to select hydrogen. Okay, then select the electron configuration tab, and then click reset. Okay, because it was on lithium, we need it to be set. We need the electron configuration to be set. All right, so electrons are arranged in orbitals, subshells, and shells. These levels of organization are shown by the boxes of the gizmo. Okay, each box represents an orbital. The subshells are labeled with letters S, P, D, and F, and the shells are labeled with numbers. Okay, so we looked at that last week. So here's the question. How are electrons arranged in elements with atomic numbers 1 through 10? All right, so there's a couple things we looked at last week, like the Aufbau principle, the Pauli exclusion principle, and Hund's rule. Okay, those are all things that you looked at last week. All right, so the Aufbau principle says that electrons occupy the lowest energy orbital. When energy is selected, the orbitals are arranged from lowest energy at the bottom to highest energy at the top. Okay, so bottom to top. Click once in the 1s box to add an electron to the only orbital in the s subshell of the first shell. Okay, so I'm going to click down here. Okay, and that's basically what it's asking me to do. Click check. What is the electron configuration of hydrogen? Okay, so check. Okay, so what is it? Well, this is what it is right here, 1s1. Okay, so you're going to have to write that in. So we're going to write 1s, and yes, you do have to use the superscript. So you're going to go to Format, Text, Superscript, and then 1. That tells me that there's one electron in the s orbital in the first energy shell. Okay, so you have to do that. So remember, to do the superscript, you're going to go to Format, Text, and then Superscript. All right. So these arrows that you see, there's going to be always one that goes up and one that goes down. Okay, there's something called spin, and so these electrons spin, okay, on their axis in different directions. Okay, and so if you have an up arrow, you must have a down arrow that comes next. Okay, so you can put that in here. The Pauli exclusion principle states that electrons sharing an orbital have opposite spins. Okay, so that's what the Pauli exclusion principle tells us. So check your work. Arrange. Click next element and create electron configurations for lithium, beryllium, and boron. Okay, so we have to go to lithium. Okay, so now you have to, I'm going to click reset. And now you have to do it for lithium. How many electrons does lithium have? Okay, it's going to have 3 because this is neutral. So I have to put, using the Pauli exclusion principle, I have put 1, 2, and then 3. All right, and so that's basically the way that you're going to do this for beryllium. Okay, and then boron. Do the exact same thing, and don't forget to put in your electron configurations into the boxes using your superscript. Okay, rearrange. Hund's rule states that electrons will occupy an empty orbital when it is available in that subshell. Rearrange the electrons within the 2p subshell and click check. All right, so here we're going to go 1, 2, 3. Oh, let's do carbon. Click next element to select carbon. Add a second electron to the first p orbital. Okay, so make sure that you're doing this in the steps. Okay, I tried to skip a little bit and ran into some trouble. All right, so this needs to have 1, 2, 3, 4, 5, 6. All right, so now I'm going to click check. And it says electrons are not properly arranged in energy levels. Okay, so based on Hund's rule, okay, what this tells me is that I have to fill up my orbits, okay, before I go back and put in another electron, okay, in the first P. All right, so this right here is, let's check that, correct electron configuration. Okay, so click here to select edit and use the drawing tool. So we're going to click edit, okay, and then you're going to want to draw those arrows in. Okay, so I think we can select arrow here, and then you're just going to draw in those arrows. Remember, one going in one direction, the other going the opposite direction. Okay, just make sure they're going in opposite directions. All right, then you're going to hit save and close. Okay, when you're done with that. All right, so that's what you're going to do for that. Compare. So make sure that you are, for this right here, I'm going to get rid of that because we didn't do that. All right, practice. In the space below, write the electron configuration for the next 4 elements: nitrogen, oxygen, fluorine, and neon. Then use the gizmo to check your work. Okay, so what they're asking you to do here is you're going to write in the electron configuration for nitrogen. So remember, 1s format, text, superscript 2. Okay, then you have to go back here to superscript. You may be able to use a shortcut. I can't. Okay, so 1s2, 2s 2. Okay, and then you're going to have to do the 2p6. 2p, and then however many you're going to have. However many electrons go in the p orbital, you're going to put that in. Don't forget to use your electron configuration over here to fill in the orbital box diagrams. Okay, so you also have to do this. So you have to have the electron configuration and the orbital box diagram. All right, so let's go ahead and reset this. Next, what you're going to do is, how do the radii of atoms change across a period? Okay, so remember, guys, the periods go from left to right. So first period, second period, third period, fourth period, and so on. Okay, and so when we add electrons, right, we're making that atom bigger, supposedly, right? We have to kind of double check and make sure that that's what happens. So predict. Positively charged protons in the nucleus of an atom are attracted to negatively charged electrons. How do you think the atomic radii will change as electrons are added to a shell? So as we add those electrons to the S, to the one first energy level, first shell, second energy level, how do you think the size of those atoms is going to change? Predict. Make a guess. Okay, and then create a proper electron configuration for sodium. All right, so remember, the electron configuration is like the 1s2, 2s2, 2p, and so on. All right, and then what you're going to do is you're going to put in the atomic radius. All right, now the atomic radius, right, when you do this, let's see. It's going to show you down here the atomic radius. Okay, atomic radius is 67 picometers. All right, so put that in here, 67 picometers, not just 67. You have to put the picometers. Okay, do the same thing for all of these that they're asking you to do. If it's asking you a question, put it in the table. So how many electrons, what's the electron configuration, and the atomic radius. Okay, how does the atomic radius change across a period? Okay, now last is select the atomic radius tab. Okay, so there's a tab up here. Okay, and so once you've added all of these in, it's going to show you some trends. It's going to show you something on this graph. Okay, so keep on doing that. All right, activity C, the diagonal rule. All right, so get the gizmo ready on the periodic table tab, select argon. So argon is down here. It's a noble gas. Okay, select the electron configuration tab, and then turn on show number of electrons. Show number of electrons. Okay, so let's read the question. How are the electron configurations of elements beyond argon determined? Okay, so what happens to the electron configuration beyond argon? All right, so create the correct electron configuration for argon, then click Next Element to go to potassium. Click once in the first 3D orbital and then click Check. It's going to give you some feedback. Write it in here. Okay. The 4s subshell is a lower energy subshell than 3D, so it is filled first. Remove the electron from the 3D orbital and place it in the 4s orbital. You do that just by clicking on the box again. Okay, so if I want to remove an electron, I can just click on the box again and it will remove the electron. Okay, is it correct? What is the configuration? Click Next Element, okay, and so make sure that you're working through all of these questions, all right, and we'll talk about the diagonal rule a little bit later. Okay, but for now, I just want you to start working on the gizmo. If you have any questions, let me know through Schoology.